Hello students. Okay, now today we discussed stress versus strain graph. In last lecture we discussed Poisson's ratio and numericals of elastic potential energy. Okay, now we discuss what stress versus strain graph. Okay, as we know, stress and strain are according to Hooke's law. According to Hooke's law, stress is proportional to strain up to 1%. It means stress means what? Restoring force per unit area. Strain means what? Change in length upon origin. So if we increase the length of wire using the deformed force, then restoring force is exert in a wire. Okay, so when we remove that force when we remove the deformed force up to 1%, then due to the restoring force, substance can get its original shape, but up to 1%. So now we discuss the graph of stress versus strain. So see students, here O, and suppose this is A, means up to A, stress and strain are proportional to each other. So students, A is known as proportional limit. Okay, why? Because up to A, stress and strain are proportional to each other. After that, they are not proportional to each other. So see, up from A to B, stress and strain are not proportional to each other, but up to B, when deformed force is removed, substance can get its original shape. So students, B is known as its elastic limit. Okay, why B is known as elastic limit? Because after point A, stress and strain are not proportional to each other, but at point B, if we remove the deformed force, then due to the restoring force, due to the stress, substance can get its original shape at point B. So at point B is known as elastic limit, but after point B, now at point C, if we remove the deforming force, then see, the substance cannot get its original shape. Okay, what is the original step at O? But now substance it reach at here. So now it is known as, C is known as permanent set, permanent defect. Sorry student. Okay, now this is its permanent position. Okay, means some shape or dimension are changed. This is the original dimension, but now this is its dimension. Chalo. So students, it is known as plastic behavior. Now if we again increase, suppose we can increase the length up to point D. Okay, we can increase the length of the substance up to point D. So D is known as its tensile strength. D is known as what? Tensile strength. And the students, see, up to C to D, if deformed force is removed, then substance cannot get its original shape. So this is known as its plastic behavior. and here substance can get its original shape, so it is its elastic behavior. And so D is tensile strength, means we can stretch up to this point only. Now after we can increase, then E is known as fracture point. Okay, means after point E substance break, so E is known as fracture point. If students distance between D and R are very close, then the substance is brittle. Okay, means substance is not strong, but it is what? Brittle. If distance between D and E are large, then substance is ductile. Okay. Means after point D at a large distance substance can break, then the substance is known as ductile, strong. If the distance between D and E is large, then substance is known as ductile. Chalo, so again I repeat students, see, up to point A stress and strain are proportional to each other, so point A is known as proportional limit. After point A, stress and strain are not proportional to each other, but at point B, if we remove the deforming force, then at point B substance can get its original shape. So B is known as elastic limit. But after point B, if we increase the deforming force, then at point C there is a permanent set in a substance. Now there is a permanent defect in a substance. So C is known as permanent set. Okay. Chalo. So if distance between up to point the C, we can stretch the substance. Okay. So D is known as its tensile strength and it is known as plastic behavior. But after point D, if we increase the length, then at point E substance can break. Okay, so E is known as fracture point. If distance between D and E is large, then it is known as brittle substance, ductile substance. Otherwise, if distance is short, less, means तरत ज substance break થઈ જાય after point D, then it is known as brittle. Chalo, so this is the what stress versus strain graph. Okay, this is the stress versus strain graph. Now we discuss bending of bridge, students. This is not very much important, student, bending, but we discuss its formula, bending, and its symbol is delta. See students, there is a this is the possible in the case of bridge, pillar of a building. Why they are bending? Due to the first due to the weight of due to its own weight, and in a bridge suppose due to the weight of vehicles, due to the force of air. So in this type of reason there is a bending in a bridge. Okay, and what is the bending, what is its formula, in which factor bending depends, how to reduce the bending of bridge, that we discuss, students. So suppose this is the bridge and distance between its 2 points is what? L. This is its depth. Okay, now see, due to its suppose what is the total weight of vehicle, weight is own weight, and in downward what is the weight? W. Okay, so now due to this weight, what is its bending? See, this is its original position. This is its original position. This is the original position of beam. But students, see, due to the its own weight, due to the weight of vehicle, there is a bending in a bridge, and now suppose in this type, this is the bending in a what? Bridge. Okay, suppose this is its original center, but now first this is the center, but now he is the center, so this is what? Its bending delta. Okay, so this is its bending delta. Now see, students, that bending delta is what? WL cube upon 4 upon 4 B D cube Y. Okay, what is the formula of bending? WL cube upon 4 B D cube Y. So see, students, W is what? Here W is a weight. Here what? W is a weight, L is a length, B is breadth, D is a depth, and Y is the Young modulus. So students, if we want to increase the if we want to reduce the bending, then increase the Young modulus. If substance that used in a formation of a bridge or in a pillar have a greater Young modulus. Okay students, अगर तमे Young modulus increase करी देसो तो bending ए शू थासे less. See, what is the formula of bending? Remember this formula? हजी सुधी નથી આવ્યું, so not so important, but તમે યાદ રાખજો. What is the formula of bending? WL cube upon 4 BD cube Y. So if we students increase the Young modulus, then we can reducing its bending. If breadth is increased, then also bending is reduced. If we increase the depth, then also bending is reduced. So see students, તમે જોજો જે પિલાર્સ હશે ને એકદમ મોટા હશે, ડેપ્થમાં હશે એકદમ. ઓકે, so why? Because due to that we reduce the બેન્ડિંગ. બટ તો પણ એક પ્રોબ્લેમ થયો સ્ટુડન્ટ, સપોઝ તમે આવા પિલર ફોર્મ કરી દીધા હેવિંગ હાઈ ડેપ્થ, ઓકે, બટ તો બી શું થશે, આનું બેન્ડિંગ એ થશે. કેવી રીતના આનું બેન્ડિંગ થઈ જાય? સી, suppose if we increase the depth, why we increase the depth, then we reduce the, if we increase the depth, then bending is decreased. So now suppose this is the original, suppose our pillar તમે જોયા હશે, but see now what is the problem, they bend like that form, bend like that form due to its weight. Okay, આવી રીતના બેન્ડિંગ થઈ જાય. So that effect is known as buckling. That effect is known as buckling effect. હવે તો સ્ટુડન્ટ્સ એ લોકો વેઇટનો ધ્યાન રાખતા હોય, પણ સી આ બકલિંગ ઇફેક્ટ એ રિડ્યુસ કરવા માટે વોટ ઇઝ ધ શેપ ઓફ પિલાર ઇઝ ઇન ધ શેપ ઓફ આઈ. કેના શેપમાં હોય સ્ટુડન્ટ્સ? આઈના શેપ. તમે જોજો કોઈ પણ ઓવરબ્રિજ હોય ને એના જે પિલાર હોય ને, જોજો એ આઈ શેપમાં હશે. ઓકે, આઈ શેપમાં આવી રીતના એ લોકો કરી દેશે ને, તમે જોજો સ્ટુડન્ટ્સ. હવે એ જે પિલાર હશે એ આઈ શેપમાં હશે. આવું છે. Okay, so due to that we can reduce the effect of buckling. Okay, આનો સ્ટુડન્ટ્સ વેઇટ લેસ થઈ જાય. સી વેઇટ આ પાર્ટ સ્મોલ થઈ ગયો તો વેઇટ સ્મોલ થાય, ડેપ્થ ઇન્ક્રીઝ થઈ જાય, સો એન્ડ પ્રાઇસ બી લેસ થાય. ઓકે, સો ઇફ ધ શેપ ઓફ પિલર ઇઝ ઇન ધ ફોર્મ ઓફ આઈ, then we can reduce the buckling. ઓકે, તો જોજો તમે બધા જે પિલાર હશે એ ક્યાં ફોર્મમાં હશે સ્ટુડન્ટ્સ? ઇન ધ ફોર્મ ઓફ આઈ. તમે ચેક કરજો, ઓવરબ્રિજ હોય તો એના પિલાર જોજો, ઓબ્ઝર્વ કરજો, તમને આઈ શેપમાં દેખાશે. ઓકે, આઈ હશે અને નીચે બી એવું. સો ઇટ ઇઝ ઇન ધ ફોર્મ ઓફ આઈ. સો ડ્યુ ટુ દેટ વી કેન રિડ્યુસ ધ ઇફેક્ટ ઓફ બકલિંગ. ઓકે, સો વોટ ઇઝ ધ ફોર્મ્યુલા ઓફ બેન્ડિંગ? WL ક્યુબ upon 4BD cube Y. Okay. Chalo, now students, we discuss one NCERT question. Chalo, what is the question? Suppose this is one support. This is very important question, student. It is a NCERT question. Chalo, and suppose there are the two wires. One is steel wire and another is what? Brass wire. Length is same. Length and cross section area, what I call, all are equal. No, area is different. Oh, sorry, length is same, area is different. And with this we can attach one rod. Okay, and this rod is what? Not moving. Okay, it is stationary. This is the rod. What is the length of rod? That is 2 meter. Chalo, okay. Now see what are the given here? Steel, and here we write brass. Chalo, so now for steel wire, what is the area of steel wire? Suppose steel is 1, is 10 raised to minus 3 meter, and for brass wire 2 into 10 raised to minus 3. Okay, and then young modulus of a steel wire is 2 into 10 raised to 11 Pascal. Young modulus of a brass wire is 10 raised to 11 Pascal. So for the steel wire and brass wire, cross section area are given, Young modulus are given. So it is a two-part question. What is the first part, students? See, what is the first part? Find position along road find position along road It is a two-part question. Find position along road at which equal for equal stress in a wire. Okay, for equal stress in a wire. So stress are equal, then what is that position? Chalo, what is the question, students? See, obviously students, when we increase the load, suppose first the steel wire, it is a copper wire, then both the end with both the wires we attach one rod. So when we attach the rod, students, then due to the weight of rod, stress and strain are produced in a wire. But we want to find the point at which we want to find position of a wire at which equal stress is in a wire, for equal stresses. So first of all, students, see, suppose we assume that point here, okay, and what is its distance from the steel wire? What is the length of rod? 2 meter. Okay, and suppose we assume what is its distance from one end? What is the distance of point from one end? Is 1 x. So what is the distance? Means suppose at point P, stress are equal, and what is its distance from one end? X. Means from steel side, what is the end? Is distance x, and from brass side, what is its distance? 2 minus x. Okay, chalo. So first of all, students, see that rod remains stationary. Okay, rod does not perform any type of rotational motion. So if rod does not perform any types of rotational motion, then it means torque is 0. It means torque means 0 means what? Torque produced. Torque means what? Due to the torque it perform rotational motion. So suppose if steel wire rotate in a anti-clockwise direction, downward, suppose clockwise, then brass wire in anti-clockwise. Okay, agar steel in a anti-clockwise, then brass in a clockwise. So due to that rod remains stationary. So we can say that that torque produced by 1 and 2 are equal in magnitude, opposite in direction. Now what is the formula of torque? Force into perpendicular distance. Suppose, and that force is what? Here we consider its tension. So what is the tension? T1. What is the perpendicular distance? X. Same for wire T2. And what is the torque? Means force into perpendicular distance. Why torque? Resultant torque is 0 because rod does not perform rotational motion, is hold it's held in a horizontal position, that is given. Okay, this is the position of rod. So T1, so we get one equation, student. T1x is equal to T2. Chalo. So we get one equation. Chalo. Now this is the general equation that we used in our A case and B case. Chalo. So this is the equation. Resultant torque is 0. So it means torque produced by the wire, steel wire, and torque produced by the brass wire are equal in magnitude, opposite in direction. Equal in magnitude. Okay, now students, see, stress in a wire are same. What is the given? Stress in wire 1 is equals to stress in wire 2. What is the given? Stress in wire 1 is equals to what? Stress in wire 2. So what is the stress in wire 1? Stress means force by area. Here we consider force as a tension force. So T1 by A1. Okay, first wire is a for steel, second is a brass wire. So T1, what is A1? 10 raised to minus 3. What is A2? So we get what? 10 raised to minus 3 cancel. So we get T2 is equals to 2T1. T2, 2 is in multiply. So T2 is equal to 2T1. Now place in value in equation number 1. So what is T2? 2T1, 2 minus x. So T1x, now see students, we can cancel T1, T1. So 2 into 2, 4, 4 minus 2x. So 3x equal to 4. So what is x? 4 by 3 means 1.33 meter. Okay, chalo, again I repeat students, see what is the question, important one students. Chalo, what is the question? One is a steel wire, another is one is a steel wire, another is a copper wire, and both the wires are attached with the what? Rod, and rod remains in a horizontal position. So we can say that torque is 0. So means both the torque produced by the steel wire and brass wire are equal in magnitude and opposite in direction. So resultant torque is 0 and rod remains in a horizontal position. So torque means what? Force into perpendicular distance. So T1, P is our reference point. So we measure the distance from P. So T1, what is the perpendicular distance? X. T2, what is the perpendicular distance? 2 minus x. So now this is the equation. Now what is the we want to find? We want to find position where stress are equal. So stress 1 equals to stress 2. So then stress means force by area, and what is the force here? Tension force. So we write T1 by A1, T2 by A2. So clear? Then we obtain what? T2 is equal to 2T1, then placed in equation 1. Chalo. Okay students, so this is our first case in which we want to find position along rod for equal stress in wire. Chalo, now it's second part, students. This is our NCERT question. Now what is the second part? Now second part is what? Equal strain in a wire. Chalo, now equal strain in a wire. Chalo, so now students strain are equal. So this is the equation, common equation, because it is related about what? Torque. So this equation we can use in both the cases. It is general. Chalo, so now strain in wire 1 is equals to strain in wire 2. But see students, here strain delta L by L is not given. So what Young modulus is given. So what is the meaning by Young modulus? Stress by strain. So strain means what? So strain means what, students? Stress upon Young modulus. Okay, and what is stress? Force by means here tension. So we write what? T1 A1 by Y1, T2 A2 by. So again I repeat students, see what is the. Now we want to find same question, but we want to find position along road for equal strain in wire. So strain in wire 1 equals to strain in wire 2, but strain is not given. Strain is not given, students, but Young modulus is given. So what is the Young modulus? Stress by strain. So strain is equals to stress upon Young modulus. Stress means force by area. So what is the strain? Here force is a tension force. So T1 A1 by Y1, T2 A2 by Y. Chalo. So what is the area of first wire of a steel wire? 10 raised to minus 3. What is its Young modulus? 2 into 10 raised to 11. Now same, what is the area? 2 into 10 raised to minus 3. And what is its Young modulus? 10 raised to 11. So all the things are cancelled. 10 raised to minus 3, 10 raised to minus 3 cancel. 2 cancel, 10 raised to 11. So T1 equal to T2. Now placed in equation 1. Now placed in equation 1. So T1x is equal to T2 into 2 minus x. Now T1 and T2 both are same. So here we write T2. T2 cancel, so x equal to 2 minus x. So 2x equal to 2. So what is x? 1 meter. Okay, what is x? 1 meter. Chalo, so we get what? Position. These are the two parts question, A and B. Chalo, now one more question from the NCERT. चलो, for a metal bulk modulus is 8 into 10 raised to 9 Pascal. Its density is 11 gram per centimeter cube. What is its original density? 11 gram per centimeter cube. What will be the density of a metal under a pressure of 2 into 10 raised to 8 Pascal? What will be density of metal under effect of under a pressure of of 2 into 10 raised to 8 Newton per meter square. Chalo, so see students, here we want to find new density. What will be the density of a metal under the pressure? So we want to find what? We want to find new density. Suppose new density is rho dash. So for that we want to find new volume. Then we get, so now new volume is what? Increase or decrease? Suppose what is the original volume V? What is the original density? This is its original density. This is its what? Original density. Okay, what is the new density? Rho dash. What is the new volume? V dash. Suppose what is the original volume? V. So now how to find, students? See, first pressure increase, because generally atmospheric pressure we consider, then it is 1 atm, but now pressure increased 2 into 10 raised to 8. So pressure increased, here pressure is increased, so volume is decreased, and so we write what? Density increased, because density, mass remain constant, student. Density is equal to mass by volume. Volume increase, density, volume decrease, density increase. So it means our answer is what? Greater than 11. Okay, because density increase. Why density increase? Because volume decrease. And why volume decrease? Because pressure increase. Okay, so now students, see here bulk modulus is given. Now here bulk modulus is given, so we can start our question from bulk modulus. Okay, so we start our question from what? Bulk modulus. And what is the bulk modulus? Minus P delta V by V. That minus indicate what? Pressure increased, volume decreased. So what is the answer of delta V by V? What is the pressure? 2 into 10 raised to 8. And what is the bulk modulus? 8 into 10 raised to 9. Units are same. Pascal means Newton per meter square. So unit are same. So 1 by 4 and 110 is remaining. So what is delta V? Minus V by 40. Now delta V means change in volume, so new final minus final minus initial. Final means new volume is V dash. So V dash equal to V minus 40. So 39 by 40. So see students, volume is decrease, है ना, because answer તમારો fraction માં આવશે. 39 by 40 means you can get 0 point something 0.975. So it means volume is decreased. Initial volume is what? V. Original volume is V, but it becomes 0.9 V. Okay, original volume is 1 V, but it is what? 0.9 V. So it is decreased. So now it is very easy. From that we get the new volume. Now see, density is equal to mass by volume. So volume is equals to what? Mass by density. Volume is equals to what? Mass by density. It is new volume, so here new density. It is original volume, so here we consider original density. Mm cancel, so rho dash is equal to reciprocal, so rho dash is equal to 40 by 39 into rho. So what is rho? 11 gram per centimeter cube. So see, density is increased. Okay, density is increased. It becomes 40 by 39 into 11. But what is the original density? 11. Now what is the new density? 40 by 39 into 11. So density increased. So what is our final answer? 440 upon 39 gram per centimeter cube. Okay, what is the original density? 440 upon 39, 440 upon 39 gram per centimeter cube. Now we discuss one theory question, students. Which of the following substances Each of the following substances has highest value of Young modulus? Which of the following substances has highest value of Young modulus? And the options are steel, rubber, wood and copper. Steel, rubber, wood and copper. Which of the following substances has highest value of Young modulus? Okay, highest value of what? Young modulus. So how to define students highest Value of Young modulus. See students, now Young modulus means what? Stress upon strain. Chalo. Now students, see, as we know, suppose for equal stresses, suppose we assume equal stress is there, then see students, suppose in which wire we produce, in which of the substance we produce large strain. So it is obvious, it is rubber. In rubber we can produce large strain, we can change it in length so far. So in a rubber, strain is max. So if strain is max, then Young modulus is minimum. But in the case of steel wire hoist students, in the case of steel, strain is minimum. For a steel, strain is minimum. So if strain is minimum, Young modulus is maximum. Chalo. Okay students, so rubber, and we can run what? Steel. Chalo. So steel have a highest Young modulus. Okay, so Young modulus of steel is maximum. And students, remember one formula, that is the relation between Young modulus, shear modulus and bulk modulus. 9 by V, 9 by Y is equals to 3 by G. G means what? Shear modulus plus 1 by V. Okay, 9 by Y equals to 3 by G plus 1 by B. Okay, this is the relation between Young modulus, shear modulus and bulk modulus.